Hello everyone, my name is Shivanesh Analaki Pavigneeswaran. I'm from DME 43 Delta and my alarm ID is 018863, and this video is dedicated for my 3D modeling project, and the model I have chosen is DC Moto. I hope you all will enjoy this video. Thank you.
Guys, so this is my DC motor project, and this is assembly view. So I have here in its isometric view. So I'm showing you all the views. This is the front view, this is the top or the plan view, this will be the right view. The right view is identical to its left view, and then we'll go to its back. Is the back view, and then this is the bottom view. So we're going back to isometric view, and then when I do this, we can see the hidden lines, the components that makes up this DC motor more clearly. So we can see the inner components more clearly, and so this will be my assembled DC motor. We'll move on to the parts right now. Okay guys, so this is my first part. The first part is called the housing. This is the housing of the DC motor. So how I made this is, we'll go here, and once we've edit sketch, this shows the base of the sketch on how I made this. So basically, first I made a circle with 20 millimeters diameter, and then there's another circle over here with 6.15 millimeter in diameters. So this circle and this circle are in geometry construction. So construction geometry, yeah, sorry. So once I've put this construction geometry, it basically makes the lines as a baseline for sketching your lines on top of it. So after these circles, I have chosen this rectangle, this center rectangle over here. So what I did is I took it from the middle, this axis, and I pulled it. So the length of this rectangle here is 15 millimeters, and I've made this as my construction geometry too. Why I did this is because after this I've chosen line. I basically did one point here and then one point here to make one straight line, and I did the same thing over here, as you can see. After this, I chose the arc position, yeah, here, this 3-point arc option over here, from here to here, and then I'll fix this inside this circle's arc, and I did the same here, so we get this shape. Alright, after that I simply boss extrude. Once I boss extrude, I get this. Once I edit feature, you can see, so this is the plane, and then there's 19 millimeters from mid plane. So what I did is, from this plane, this plane, it will go from both sides. Because I chose this as the mid plane, it will go from both sides, both axes. Okay, and then we'll move on to the next. I chose fillet option to make these rounded edges of the housing, and then there's another fillet to the top and also the bottom of this. So for the fillet one, you can see I've chosen 1.7 millimeters and 2.3 millimeters as my fillet parameters. Okay. Then as for fillet 2, we can see 1.25 because this is a symmetric fillet. Okay. And then boss extrude. For this boss extrude, I've made a circle right in the middle here, and then I extrude it for 1.75 millimeters, and then I fillet this area, this edge, for 1 millimeter. And then moving on to the next, I shell this over here, this part, because this is an housing, it has to go and accommodate other inner components. So for the shell, we can see I have chosen this face and this face, and the parameters are 0.375. So this is basically the thickness. And then after doing that, move to cut extrude. This cut extrude over here is here and also here. So how I did this is I chose the rectangular option from the middle and I pulled it up here with 1.5 millimeter length. So then I went to surface revolve over here, this part and here, and then I move to thicken. Yeah, so then I went to surface revolve, which you can see over here. I did a sketch. So this sketch, you can look over here. I made this curved line, this arc, and then this straight line. This arc has a radius of 0.75 degrees and then 1.25 millimeter in length for the straight line. So then I will surface revolve this over here. After doing that, I thicken the line. So what happens basically is that you see this line over here. I am making this particular line to thicken a few centimeters, which is 0.38. Okay, and then I am mirroring it. So this part over here has the same feature. So I mirror it about the right plane. So this feature can be mirrored to the other side easily. Next, I'm going for cut extrude. Cut extrude over here above this hole. So you can see it has a 1.5 millimeter in diameter, and I fixed its position up from this hole, from this axis is 5 millimeter. After doing that, I go to another cut extrude, which are the sides, these holes over here and here. So if you can see this rectangular over here, it's straight in line with the axis. So this is a center rectangle with 2 by 4 millimeters, and then basically just cut extrude through all. After doing that, I fillet. Yeah, So I fillet this part over here. The fillet is 0.5 millimeter degree, and then moving on, we have the loft. For this loft, I had two sketches. So to have a proper look, we'll go to this. So I made this sketch over here, these straight lines. I made this point and this point as an arc, and then there's this. So basically, after making this arc, I can bend it to my will using these little connectors kind of thing. So there are 2.25 and 2.25 in arc radius. So this one has a 4 millimeter distance, and I did the same arc. I repeated it with a distance over here, just right in front of it. So this distance is 0.38. So we will go back to normal view, and then there's this other sketch. This other sketch is over here. These 4 lines. So why I made these 4 lines is for the lofted area. For this area to loft, I had to convert the entities, and then only I can loft this segment to get that perfect curvature. So when I loft it, this is how it becomes. Choose the area chosen, sketch 9, and then this is sketch 8. So when I loft it, I loft this face to this face, and the metallic parts will bend from here to here with this part excluded. So this part is excluded, okay? So then I mirror this feature to here. It is mirrored on the right plane. And then moving on, we have the cut extrude. So this cut extrude is at the bottom of this housing. So we'll have a look at the sketch. So there's a straight line, straight line, straight line, another curve, straight line, a slight curve over here, and then there's another curve over here. So you can see the distance is all been made up. So first of all, how I did this is I made a center rectangle, pulled it up, and then with a distance of 2.66 by 6 millimeters. And after that, I had to make a construction geometry. After making the construction geometry, I build the lines as straight line 1, straight line 2, curve, straight line 3, and then there's a slight curve over here, and then there's a before this I had to make another center rectangle. So if you can see this line over here, so what happens is this part and this part, it joins. So from this corner to this corner, so there's a straight line, there's a curve, and then there's another straight line back. Okay, so after doing that, I cut extrude it up to next. I chose this up to next because it will have to bend a bit inside, and then what we do is, moving on, we boss extrude. Okay, boss extrude up to the face, and then we body move or copy. So what happens here, is this particular edge over here. This edge is going inside for negative 13 degrees, like this is how it looks inside negative 13 degrees. And then boss extrude over here. For this boss extrude, I just have to fill the gap between this plane and then the angled part over here. So there will be a gap here. So to fill in this gap, I have to boss extrude. So I go to edit sketch. As you can see, there's this line. We convert the entities and then simply enter boss extrude. So it will fill from here up to here. After doing that, I mirror this feature over here, again using the right plane, and then I use the fillet feature over here and also over here to smoothen those two parts. And then as final feature, we cut extrude over here for this purpose is for the cover of the DC motor to join this housing later. So for this cut extrude, we go to the sketch. It's another center rectangle with 1 by 2.5 millimeters. So this is a simple feature, and then so that's it. This is the first part of our DC motor, and it's called the housing. Okay, so this is our second part. This is the cover for our DC motor. This is how it looks. So we start this by going up over here and we look at the sketch. Okay, so here we start off by making this circle, and then we choose it as our construction geometry, and then we make this rectangle just how we did in the first part. We choose everything as our construction geometry first with 15 millimeters in length and 20 millimeters in diameter for the circle. So after doing that, we build our lines on top of the construction geometry. There's straight line 1, straight line 2, and then closed by this arc over here and also over here. So you guys can see. Next, moving on, we boss extrude our sketch 5 millimeters. Alright, after that, we make a circle just at the center with 8 millimeters in diameter, and then we will boss extrude this circle just for 2 millimeters in distance, and then we will go for fillet 1. Fillet 1 is exactly like how we did for part 1. Okay, so we look at the feature again. There's 1.7 by 2.3, and this is asymmetric. It means they are not same in both sides. Okay, and then after that we go to fillet 2, top and the bottom. So these are the dimensions, 1.25 millimeters, and then there's boss extrude. So for this boss extrude, we are making another sketch Okay, this sketch over here, you can see there's a point over here, so that's basically an arc. Over here too, there's an arc over here, over here, and over here, and over here. So with only two straight lines here and here, we make this arc 0.87, 0.87, and goes the same for both up here and then 9.67. Basically it has a distance, these arcs. The parameters are 0.25, and after doing that, we box extrude the feature. So this feature then comes in front 1.5 millimeter in distance. Okay, so we will be doing the same thing with the parameters of 0.25 this time, and then we boss extrude the feature 1.5 millimeter. Okay, so then we cut extrude. For cut extrude, we have to look at the sketch. So this is a sketch. So look at the sketch. What I did is basically this straight line over here, and then there are two arcs. So the distance between here and this arc is 0.75, 0.75, and then I made this center rectangle. Okay, I made it as a construction geometry, and then there is another center rectangle here, another construction geometry with this distance 12.75 millimeters, and here is 15 millimeters in distance. Okay, so then the distance of here to here is 2 millimeters, and then the center rectangle will be 4 millimeters. So after doing this, we convert the entities, and then we'll make two straight lines over here, and then connecting this arc and this point over here with straight lines, and we'll repeat the same thing at the bottom, and then that's how we get our sketch. After getting the sketch, we will cut extrude for 6.5 millimeter in distance. It will go up to this area. After doing the cut extrude, we are going to fillet. This is just an additional feature. We choose all these edges, there are 12 edges over here, 6 here and 6 here. There are symmetry edges with 1 millimeter degree, and then after doing that, we go to the cut extrude at the sides of the covers. So for this cut extrude, we're going to look at the sketches. Basically, there's a center rectangle over here made with the construction geometry, and after doing this, there's the dimensions are 2 by 3 millimeters, and then joining this construction geometry is these straight lines with this arc over here with 1.5 degree radius. And then what happens is I cut extrude both parts, and then I cut extrude the middle. So the middle, it's the point is its axis with 2.10 millimeters in diameter. After that, we're going to fillet the part over here, the boss extruded part, for here 0.25 millimeters, and then we're going to fillet the parts that we have cut extruded at the sides for 0.10 millimeters. After doing that, we're going to cut extrude here beside the circle. We'll look at the sketch. These are center rectangle, dimensions 2.8 and 0.4 millimeters. So they are symmetry. And then we will exit the sketch, cut extrude, and then we look, it's cut through all, so it doesn't have a dimension. And then we will fillet the back of the cover. Just to look at this, yeah, so the in front, so it's here and also here. Okay, and then go to the boss extrude. Looking at this sketch over here I made, so there is two straight lines and then one arc, and this arc I've made it with the straight slot, this option over here. After doing the straight slot, we boss extrude this feature for 4 millimeters. So this is how it will look. And then we go to the cut extrude of this part. Look at the sketch. So there is a circle above this circle, a bigger one with 6 millimeters. And then we edit the feature. We look that this circle, it cuts up to here, but it's not cutting the whole part. Yeah, it has a distance of 2.5 millimeters. And then we chamfer these areas, this part over here for 45 degrees and 0.25 distance. So this is our second part, the cover of the DC motor. Okay, so this will be the third part of the DC motor. So we choose the front plane first. So normal 2. This is how we will make our sketch. So there's this. Okay, so if you look at this sketch over here, first of all there is a straight line, and then the straight line is made a construction geometry. So basically how I did this was using the straight slot feature. After doing that, I have to change it to construction geometry. Once I've done that, I'll do a straight line and then an arc with 0.7, 3 point, you can see the dimensions at the side, and then there's another straight line, and then there's another bigger arc over here. So this bigger arc has a radius of 1 millimeter, and then there's a straight line ending this part, which is 5.5 millimeter. After that, we have the base bend. We look at the base flange feature. The base flange feature, basically it's like a thicken or boss extrude feature for these curves and everything. So it is brought up for 2.5 millimeter in distance, and after doing that, there's a base bend and also base bend 2. So these are the parts of the base flange. Okay, after that there is here boss extrude. Why we boss extrude here is we look at this sketch. The first straight line, we make a rectangular over here and then change it to construction geometry, or convert entities, sorry. We convert the entities, and then what we do is we boss extrude it for 4.5 millimeter in thickness. After doing that, we go to the cut extrude. We cut extrude a small portion of the extra boss extrude, so there is a corner rectangle over here. We convert these entities, and then you can see that the dimension of this particular rectangle is 1 millimeter. And then after sketching that, we will cut extrude through all. So have a look. After doing that, we will go to the fillet. At this fillet, we are curving this part, this edge over here. We are giving it a curvature. And how I did this is I chose 3 parts: part 1, part 2, and also part 3. These 3 sides, these 3 faces, to make this fillet. Okay guys, so this is our last part. This part is called the rotor, and unlike the previous parts we've done before, this is a single part. It is not assembled. So as you guys can see, there are multiple, it looks like it has multiple parts. Yes, it does, but then it is all made within one single part. Okay guys, so looking at how we did this, we'll move up. Okay, so at the front plane, we're going to do our first sketch, which is again another simple circle with 2 millimeters in diameter. After this, we're going to exit sketch and then boss extrude this with mid-plane feature, and then the distance will be 38 millimeters. After this, we will move to our chamfer. Our chamfer is that we're going to chamfer this area over here, and then another edge over here, both edges for 45 degrees, and the distance will be 0.2 millimeters. And after doing that, so you can have a look here, these are the chamfered edges. Yep. So we're going to another sketch. Okay guys, so when we edit the sketch, we can have a look at the big sketch of this one part here. This part is called the core disc. So what happens is that I'm going to make a circle just above this shaft, and then after this shaft there's another circle. Okay, so one circle and then another circle over here. After that, we're going to make this circle as a construction geometry, same with this one over here. After changing this to construction geometry, we're going to smart dimension it for 2 millimeters distance. Okay guys, so after applying 2 millimeter distance, we're going to move towards the bigger circle. So the bigger circle will be 13 over here, and then the smaller one will be 4.5. Okay, so there's this bigger circle that I've made, and I've made it to construction geometry. After doing that, I'm going back here over the shaft and making a center rectangle, And then after making this rectangle over here, I'm going to make another rectangle starting from this point to here, and you can have a look at the dimensions, 4.45 by 2.25, and then this one we will so this one will have 0.5 millimeter, and then from this edge to the axis we'll have 1.57 millimeters over here. Okay, so what happens next is that we're going to make this distance from the axis to this is 4.45, as I've said before, and then we're going to insert a line. So what line we're going to insert is that this particular arc over here, this one, this arc. So we're going to go for this option, the 3-point arc. So the first point will be here, second point will be here, and third point will be the middle. Okay guys, so after choosing the arc, we're going to make a line, a simple line here, and then we're going to move for another line over here. After making these lines, what we're going to do is that we're going to join these lines, this one over here and here. We're going to make a point with distance, and then after doing that, we're going to apply smart dimension for the lines, 0.75, and it should be same with this line. After that, we're going to make apply smart dimension for the arc, which is 100 degrees. After applying 100 degrees, we're going to move on to this line over here. So what we're going to do is we're going to apply a straight line from this point to this point, you can see, and then there's this point to this point. After applying this straight line, we're going to make another straight line from this point to this point. Same goes for this point and this point, making this whole core disc. So after that, we can have a sketch like this. Okay, have a look, and then what happens next is we're going to boss extrude our core disc, and we're going to boss extrude for 3.8 millimeters with offset, not sketch plane. We're going to choose the offset option, and then we're going to 3.8 millimeters, and this distance will be 0.5 millimeter depth. Okay, so the selected contours are these: sketch region 1 and sketch region 2, this one up here and the circular one. So after doing that, we're going to move on to the fillet. So we're going to apply fillet feature over here, this edge, and also this edge over here. Okay guys, so the edges chosen are already here. There are 1, 2, 3, 4, 5 and 6. So 1, 2, 3, just like before guys. It's 1, 2, and then there's 1 and 2. So both edges are chosen, and once we've done that, the fillet is going to apply. Okay guys, So moving to the second fillet, which will be for this part over here. So look at the difference. This is a straight point and there's a corner over here. To avoid that, I'm going to apply a second fillet. So for this fillet, we're going to apply 2.25 millimeter in radius, and after doing that, we're going to choose the circular pattern. So if you go here, linear sketch patterns, you can have a look at this circular pattern feature. So what it's going to do is that we're going to make this one core disk, we're going to multiply it by 3. Okay, so this part is going here, number 3. So it's going to be a multiple of 3 core disks after this, which is this as a reference. So once we've done that, you can have a look. There's the combine feature. What we're going to do is we're going to combine all 3 separate parts to become one. So yep, so you can have a look over there. Okay, so circular pattern 1, circular pattern 1, and then fillet 2. Okay guys, so once it is added, we can move to our chamfer. We're basically going to chamfer both faces, phase 1 and phase 2, with 0.5 millimeter distance and then 45-degree angles. So after doing that, going for the linear patterns, which is all of these whole core disks. Okay guys, so for these core disks, this one, so we look at the feature, going to choose edge, and then the direction, we can change the direction to here, and then the spacing will be 0.5 millimeter with a multiple of 16 core disks. Okay, so once we've done that, we have our core disks, and then we're going to here, we're going to make this part over here. Okay guys, so how we're going to do it, let's look at the sketch. So this is basically the top plane. We're going to sketch at the top plane, and then once we look at this one over here, so what I do basically is once you're close enough, your cursor is close enough to this line, the edge of the shaft, going to click it and then change it to construction geometry. Once you've done that, you can choose to draw on it. So you're going to make lines from this point to here and here, following straight lines, and then we're going to apply smart dimension to here is 0.5 millimeters, and this will be 1.2 millimeters, and this, the distance will be 2.25 millimeters, and then this edge will be 2 millimeters, and here will be 1.25, whereas here is 1.2 millimeters. So finally, once we've had that edge, this sketch is completed. After that, we're going to exit the sketch and then look at the revolve. So for this part over here, we're going to choose the revolve feature. So you can look here, the revolved base and revolved boss or base feature. So we're going to choose this line 1. So line 1 is a simple line. You have to choose the line feature and then use the center line from this point nearly to the axis to the end of the shaft and choose it to be the center line. After that, you can choose this line to be the axis of revolution, and the direction will be 360 degrees, because we don't want any openings or incomplete revolutions of this part. So what this part is going to be is that this is where our connectors and holders of the coils will be. Okay, so after doing that, yep, we will have this part. Okay guys, so next we will have our, wait a minute, yeah, so okay, our cut extrude. So what's happening here is that we're going to make another sketch on our part that we just created. So how we're going to do this is that we're going to select this face and we're going to select this line and we're going to convert its entity and set its offset to 0.25. okay, so it's going to move away from here to here. There's a 0.25 distance, and after doing that we are going to make a rectangular over here. So this rectangular, we are going to choose it as our construction geometry. After choosing it as our construction geometry, we're going to set our smart dimension as 1.25. As you can see, after doing that, you're basically wanting to choose this line over here, and then going to control and hold the control with this line over here, and then you're going to set this edge and the lines as tangent. So once you've chosen the tangent properties, this is how your rectangular is going to look like. Okay, once you've done that, you're going to no yeah, so once you've done that, you're going to choose a circular pattern. So yeah, this one over here. Once you've chosen the circular pattern, you're going to choose this face and then choose it as much as 6 numbers. Okay, so 6 rectangulars is going to appear around the body. After doing that, you're going to have this sketch over here. Okay, so once you've done that, you can decide to exit the sketch, and then we can cut extrude. During this cut extrude, what we're going to do is we're only going to select the parts, this rectangular, not the whole rectangular. The parts that are selected are the offset line. Just now we set this line to offset 0.25 over here, so we're going to choose the space between these both of these lines. So this whole ring over here, and then the remaining of the rectangles. So the remaining of the 6 rectangles and this one ring, and you can look at the selected contours over here. Okay, so it will highlight each and every part that are selected. So yeah, after selecting all this, we can choose to cut extrude with 1.25 millimeter distance. So you can see it's going up to this area, and once we have done that, we will have this shape. Okay guys, once we get this, we're going to move and chamfer this area, this edge. So once you've chosen this edge over here, okay, alright, so as usual, I'm going to set its distance for 0.5 millimeters, and then we're going to click the chamfer. So this edge is now chamfered. Okay, after doing that, we will go to the fillet, and once you've chosen the fillet part, we're only going to fillet the edges of these parts that we have cut. Okay, so once you've chosen this face over here, it's going to select all of those edges for 0.07 millimeters radius. Okay, so once you've done that, we're going to move to boss extrude. So for this boss extrude, we're going to make our first contact. Okay, we will look at the sketch. So we're going to again make a line. So a line from this circle to this circle, it's a simple one, and another line, this circle to here. So you can look, this one is connecting to the axis and this is 2, and we will insert these lines over here. After doing that, we're going to coincident these lines, okay, with this line, and then we're going to choose the coincident. Okay, as you can see, there's coincident number 1, that's number 5, and then there's number 8. Okay, after doing that, we're going to smart dimension our arc over here, which is 110 degrees. After doing these 110 degrees, what we're going to do is that we have our sketch of our contact here. This is the base of the sketch. So what we're going to do next is that we're going to exit sketch, and then we're going to boss extrude that sketch. So for 4.75 millimeter depth, it's going to come up to this area with the sketch plane, and then we're going to move to expand the contact. We're going to make another sketch on top of the contact. So what we're going to do now is we're going to make this line over here, straight line, and then we're going to make one big arc. So there's one big arc, and then we're going to make another straight line following this shape, another arc, another straight line, and then another arc. But this one we are not going to close it entirely, we're going to connect it here. After connecting it here, we're going to choose only this line to become our construction geometry. After doing that, we have this so as our base for this shape of our line. So this is made with our again straight slot. So once we have chosen this straight slot, you can see the parameters as such. Okay, after following these lines, we're going to smart dimension it. Smart dimensioning it for 0.35 for this line, and then this arc will be 0.17. This arc will have 0.17, the same, and this arc will have a 0.4 radius. Okay, so it has a few relations. So there's tangent 1, it's tangent to this line, and then there's tangent 2, it's this tangent will make this curve tangent to this line, and then there's tangent 13, which basically makes that this line that we have just made it as construction geometry, it's going to tangent with this arc over here, and then there's coincident for both here and here. After doing that, we have our sketch now with fully dimensioned. After dimensioning them, we're going to surface extrude just as the way we did earlier. So for the surface extrude, it's going to look like this for 1.25 millimeters in distance. After that, we're going to okay, so then we're going to use the surface extrude feature to extrude our sketch here. If you can see, we edit the feature and then we're going to use the blind option, and the distance is going to be 1.25 millimeters. Okay, so this is how it's going to look, and this is the part of our contact. This is the contact, and this will be our coil holder, which holds the coil later on. Okay, so once we've done that, we're going to thicken this surface extrude. So once we've added the feature, you can look, we are thickening it for 0.2 millimeters. So from this, it's going to go here, up here. You can go up, you can go down, you can go in the middle. So we're going to choose it, go up. Okay, and then we're going to thicken it. Once we've thickened it, we now have our coil holder. After finishing our coil holder, we're going to fillet a few parts, which are these edges, these two edges. So you can see H1 and H2 for 0.15 millimeter radius. They are symmetry. And then there's another fillet. We're going to fillet these two lower parts over here, parts of the contacts. So for 0.25 millimeters. After doing that, we're going to combine both of the coil holder and also the contact as one single part. So what we're going to do is that we're going to go for the combine feature and simply fillet 1 and fillet 2. So here is it's stated as fillet 4 and fillet 5, but I call it fillet 1 and fillet 2 because there are only two parts here. So there's fillet 4 and fillet 5. We're going to choose both of these parts and then combine it as one part. So after that, it becomes one single part over here. Nextly, there's fillet 6. We're going to edit the feature and then have a look. We are going to do the same fillet that we applied down here to above. So yep, there, you can see it here, H1 and H2, H1 and H2 for 0.25 millimeter radius. And then, so this is how it's going to look. After doing that, we're going for fillet 7. Fillet 7 basically is we are applying fillet to the whole body. All the edges are covered. So there's face 1, and then there's face 2. This is face 2. This edge, this side of the part, and face 1 will be this side of the part for 0.05 millimeters. And then we're going to again here. So after the fillet, we're going to boss extrude 4, and the sketch are two coils over here. We're going to edit the sketch, and basically how we're going to do this is that we're going to make two circles, 1 and 2, and what we're going to do is equal radius. We're going to choose this circle and control hole and choose this circle, arc 1, arc 2, they're going to be in equal radius. Okay, so after the equal radius, we're going to do this. They are going to stick like this, and then we're going to simply boss extrude them face 1, choosing both of them up to surface. So which surface we are using is here. This is the surface that we have chosen, and they will only boss extrude until this far, no more longer. Okay, so this will be the coil joints. After we have done our coil, this is where our coils will join. Okay, so moving on, there's the circular pattern too. What we're going to do is we're going to select this part. Okay, our contact and our coil holder. So there's contact 1 and then boss extrude. We're going to choose this. Only one part of the coil here, the coil joint. Okay, so we're going to boss extrude. We're going to choose the boss extrude and also the contact 1, and then we're going to make 3 multiples of it. So we've chosen it, selected 3 with 360-degree angles, and then once we've done it, we will have 3 identical contacts. Okay, guys, we will have 3 identical contacts over here. Once we have that, going on to boss extrude 5, which is now we're moving on to our coils. So how to make these coils is that we need 1, 2, 3, 4, 5, 6 and 7 circles arranged in this manner. Once they are arranged, what we're going to do is we're going to smart dimension each one of it for 0.34. Okay, once we have the smart dimension one circle over here, we can choose to make the other circles as equal. So you can see all the circles are in equal dimensions, equal diameters, radius. Okay, so after doing that, we're going to have a spacing dimension between the center points of each circles, each pairs for 0.36 millimeters. So we're going to apply this one to all the other circles. As you can see, there's 0.36, there's 0.36, there's 0.36, there's 0.36 between every single point of the circles. Okay, guys, so once we have that, what we're going to do is we're going to boss extrude those circles, vertex 1 up to vertex. The vertex 1 will be here, this point over here. Okay, guys, so once we've chosen that, the circles here are now going to make this side of the whole coil. Okay, so there's vertex 1 and then there's a vertex 2, so we're going to do the same thing with both sides. After applying that, now we have this side of our coils. Okay, once we have that, we're going to simply mirror. We're going to use our right plane, and then now our coil is going to be copied at this side of the core disc. Okay, so we've chosen all 1, 2, 3, 4, 5, 6, 7 coils. We're going to mirror them. Once you have mirrored them, we'll have this. Okay, once we have this, now we're moving on to another boss extrude, which is this side of the coil. So if you look at the sketch, yeah, so what we're going to do is we're going to start off with one circle, making this one circle here close to the edge of this face, and then we're going to use this dimension between this center point and also this point over here. We're going to set as 0 distance. Okay, once we've done that, we're going to do the same thing that we've done before. We're going to smart dimension this circle for 0.34 millimeters, and then repeat the whole process. 1, 2, 3, 4, 5, 6, 7 circles with 0.36 millimeters spacing between each center points of the circles. So once you've done that, it's going to be aligned like this, close to the surface of this core disc. After that, what we are going to do is boss extrude. Yes, so we're going to boss extrude from one point here to another point here. Okay, it doesn't matter, you can take this point or you can take this point. It's going to be the same as long as it only extrudes within this constraint. Okay, you can see this line, you cannot go further. Okay, so once you've done that, we have this side of our coils, and what we're going to do now is we're going to create a plane. As you can see, there's plane 1, and this plane is the middle, the center of our core disc. So after creating this plane 1, what we're going to do is we're going to mirror. Okay, so what we're going to mirror is these 7 coils at this face. We're going to put it back here. Okay, so we're going to choose all 7 of them, all 7, and once you've copied, so there we have 1, 2, 3, 4, 5, 6, 7 coils again. And after that, what we're going to do is we're going to use this feature. It's called lofted boss or base, and what this feature basically does is, if you look at the feature, we're going to choose one edge and another edge, and then you can either choose an edge or a face, doesn't matter. So for me here, I've choose face 1 and face 2, and we're going to use normal to profile constraint at both start and end constraints, and then we're going to uh, uncheck the merge result and merge tangent faces, and then simply we're going to tick, and after that what it's going to do is it's going to connect both of these coils, making it look realistic. Okay, so what we're going to do is we're going to repeat the same step for each connection. So loft 2, there's loft 3, loft 4, there's loft 5, there's loft 6 over here, and then the final loft here will be loft 7. Okay, so for loft 7 it's a bit special because it cannot overlap. So what we have to do is we have to make sure it doesn't overlaps. Okay, once we've adjusted its directions, now we have one complete connection between both coils. So what we're going to do now after this is, if you have already guessed it, yes, then we're going to mirror it to the other side. So yeah, we have this part of the coils are also now joined, after which we're going to plane at we're going to use our right plane to mirror this and choose all 7 lofts over here, and then plane it at our right plane. We're going to mirror this here. After doing that, we can now move to the next part, body delete and keep 1. So what we're doing here is, yeah, we're going to delete these parts over here. Okay, we're going to delete these parts. Why are we doing it? Because we want to cross section our coils here now. So how we cross section is, we're going to edit feature, choose the same lofted boss or base. We're going to choose here the edge, here I've chosen the edge. So going to start with the second circle here from down and the first circle here from down. Once you've done that, you're going to go like this, edge 1, and then you're going to check here. Previously there were coils here, right? The straight ones. But then we've used the body delete function, and after deleting them, what remains here are the sketches. You can see here the sketches. So we're going to check the sketches, the closed loop over here, okay, as you can see, and then our edge over here. After that, we're going to do the normal routine, normal to profile, and then as usual, don't forget to merge result and then uncheck merge tangent faces. After doing that, yes, now you have your conjoined coil. So we're going to repeat the same feature a few more times. Here you can see, but for loft 15 it's a bit special again because it cannot overlap. So what we're going to do is that at this edge we're going to adjust the direction and then put the end constraint as 1.7, so it will be lifted a bit higher like this to make it more realistic. Okay, so yep, normal to profile, if it's only 1 then it's going to overlap. So if it's 1.5 like this, it's going up a bit, isn't it? But it's not fully open. As you can see here, it's still overlapping this area. So we're choosing 1.7 to be safe, and it's now free. Okay, after doing that, we have this part here conjoined, and now moving on to loft 16 is where we're going to connect our normal coil to our coil connectors. So going to edit feature, basically it's the same thing, but this time we're going to choose two edges and normal to profile while choosing this one up here at the start constraint as number 2. So it's basically the function we're doing this is to make the coils look more realistic as coils bend in real life, and then we don't want it to look too much, we don't want to give it more corners. Okay, so once we've done that, we have this coil connected over here, look like this. Okay, and then after that we're going for the next conjoint coil, which is loft 17. As we look into the feature, yeah, so the previous circle at the bottom one here, we're going to check that, and then another uh, coil connector over here. So once you've chosen both of those edges, we're going to apply normal to profile and normal to profile constraints, and we're going to check them. So this is how it will look. So this is one perfect coilover. Okay guys, so after that we're going to combine them. If you ask what we're going to combine, so without this command, these coils previously, they are in one, they are solitary. Yeah, they are solitary. So if you choose this coil, it's going to be one singular coil, and this will be one, each of its each coil will be in its own isolation. Okay, so once we choose the combine feature, what we're going to do is simply combine the whole coil. It's going to be one whole coil. We're going to check every single coil sketches, boss extrudes we have made, and also the lofts, not to forget the lofts, the edges, the corners, everything, and we're going to check them all. So here's the preview. once we've done that, we're going to add, and here it now is one whole coil. Okay guys, this whole coil is now connected without any isolations. So nextly, we're going for the circular pattern. Okay, what we're going to do is we're going to choose this our combine, and then we're going to multiply it by 3 for the other core discs. After doing this, we now have our whole rotor, as you can see. Yeah, so once you've done that, even the coil joints are now connected and there are no left out coils over here. So the final feature we'll be doing is we will be combining here all of the coils again, circular pattern, everything, and we're going to combine 3 is our primary coil that we've done, and then the boss extrudes will be the small portions of our coils that we've left before. So we're going to combine all that, and now truly all the coils are now one single coil, and we have our rotor completed. Okay guys, so this is all for our rotor part, and there are 22 solid bodies right now with 3 contacts, as you can see, with 16 core discs, these ones. Okay, and then we got our shaft, and then we got our contacts holder, which is this part, and then we have our coil. So there are 5 different components. Some are multiplied by 16 and also 3. So now we have 22 solid bodies in total. So this is for the rotor part. Okay. Okay guys, now we're back at the assembly part. So now what I'm going to do is I will show you how to create this whole DC motor assembly, how to assemble all the parts into making one complete DC motor. So what we're going to do is going to have an axis first. So we put this here, okay, and then next we're going to bring our parts. Okay, so now we're going to bring our parts. As you can see, I have my file manager right beside me. So what we're going to do now is we're going to bring our cover first, our part 2, and we're going to fix it here. Okay, as you can see right there, we're going to point our cursor to our axis, and we're going to fix it there. Okay, so now you can see here, can see here there's an F, meaning this part here, the second part, and the cover is now fixed with this axis. And next what we're going to do is you can have a look. Okay, so what we add the front plane, normal 2. So this is at our front plane right now. Alright, and now that we have fixed with our axis, we don't need this anymore. Okay, so yeah, it's free to observe if you want to make any changes, but I'm not going to make any changes right now. So what we're going to do next is that we're going to import our second component, which is this, our part number 6. Okay, our bushing. So what we're going to do is we're going to bring this bush close to where it's going to go. So it's going to go like this. Okay, so this is where it will be going. Now what we're going to do is bring this out. What we're going to do is we have to select this face, and then we're going to mate this. Choose mate, and then we're going to mate it here. Okay, so once we've selected this face, it's going to go sit right there. Okay guys, so yep, it's now in coincident mate. The bushing is now mated with the cover using coincident mate. Okay, nextly what we're going to do is we're going to bring in our next part, which is our this. Okay, so what we're going to do, you can rotate it this way, and then once you've done, just take this, and now we can put it here. Okay, so what we're going to do now is we're going to make this component over here. So we're going to check this part, and we're going to mate it with the edge that's going to go and sit, which is here. So once we've made it, it's now going to go coincident. It's going to show us coincident. Okay, and then you're going to select it, but you can see that it's not rightly at its position where it's supposed to be. What we're going to do next is that we're going to advanced mates, and we're going to go with. Okay, advanced with, and select this and this faces as our width selections, and then where the widths are going to go, it will be our tab selections, is this and also this. So now you can notice it that it's now in its place. So once we move this component over here, it will only go in and out of its designated hole. Okay, I'm going to tick that, and then we can move this. As you can see, it cannot go up and down, it can only go to its place. Okay guys, yeah. So nextly what we're going to do is we're going to do this. We're going for assembly, and then circular component patterns. As you can see, going to take circular component patterns, and then for the direction we're going to choose the place where the shaft is going to go. This will be referenced as our midpoint, so you can see, and then going to go for equal spacing over here, what we're basically going to do is components to pattern, click it, and then we're going to tick this. So what we have now is an identical of this component over here. See, we don't have to be importing another component, because with this feature circular pattern we already have this part over here, and we're going to tick. So now we have two identical parts moving along together. Okay, yeah, so now what we're going to do is that we can see how far this is moving, and then we're going to go for isometric view to have a proper look. What we're going to do next is we're going to bring in our next part, which is our housing. Okay, so this is our housing. What we're going to do now is we zoom in, and we're going to mate this part with our housing. Just right here it will do, mate, and here, yep. So you can see now that the parts are fixed at its correct position. You can move it now up and above, I mean up and down. You can rotate it, but all you can do with this part right now is it will not run from its axis. Okay, so next what we're going to do is going to make it fixed by not rotating. I'm going to select this part and this part. Okay, mate with this, and we're going to make it coincident. Sorry, okay, so now we're going to make this with this. Yeah, just like this. It will not run from its rotation anymore. It will not rotate. It will just go front and back. The next is that we can have a look, and then we're going to make this again. Like this is how it should look once it is mated. Okay, so before we fix this part, we're going to have a sectional view from here. Yep, so from here you have a full view of the insides of the DC motor. You can see how it looks from the inside. And what we're going to do now is we're going to insert our next part, which is the magnets here. Okay, now you can't actually see the magnet because it is in sectional view, but once I've unclicked it here, you can have a look. This is sectional view, and this is how it's going to look. It will still move up and down. It can rotate and can move like this. So what we want to do is we want the magnet to stay fixed with this part over here that we've made, and also this part. These two are functioning now as a holder for this particular magnet. Okay, so how we're going to do it is like this. To fix the magnet in place like this, choosing one side of this, going to mate it with the part that we lofted, and we're going to tick it. So now this thing will not move away from there. Can rotate, yes, but will not move. To make it unable to rotate, what we're going to do is going to select this part, this side, and fix it with this edge. Okay, now we've done that. It's symmetrical, it's coincidental, and we're going to tick it, and there we go. The magnet now is fixed at its place and it will not run. So that's how we do it. Nextly, what we're going to do is here, for a proper look, we're going to hide this component. So yeah, that's how it's going to look. Okay, nextly we're going to cut the cross sectional, and then we're going to show components. We will bring in our next part, which is our spacer. Okay, so we're going to make this part, make this tower face over here. It's going to be coincidental, and yes, that's all. So now you can see it's going to move on top of the surface of this inner housing, right? So what we're going to do next is that we're going to mate this spacer for a second time by choosing the other edge of this. Like, okay, so what we're going to do now is, before that, using the top plane. Yeah, so we will have better visibility over the part. So what we're going to do is zoom in. We're going to mate this with this face over here. Okay, so and then we will tick this. Now what the spacer can do is, it is fixed inside the inner housing, but it can still move from left to right like this, right? So now we have this in place. We need another part of this magnet for us to fix this spacer at its place. So what we're going to do now is go to the right plane, click it, and then what we're going to do is going to go for mirror components. So to mirror components, I'm going to click this magnet over here. Once you've done that, and now we have two magnets. Okay, alright, so after that we're going to go for mate, advanced mate, and width, and we're going to select this, and this face of our magnet as our width selected, and then we're going to choose this and this face, and you see it's automatically aligned. So then that's all. The spacer is now fixed at its place and it will not move, as you can see. Yep. Okay, so now once we have done this made, we can now move our bushing, our second bushing. So what we have to do next is, so now we will go to the right plane, and then we will do the sectional view. Alright, so once doing that, what we will do is we can see where this bush is going more clearly. Okay, to mate this part over here with this edge, and then there we go, we will have this part mated perfectly. It will only rotate at here. Going to insert our final part, the rotor. So to look at the rotor, there, have it here. Okay guys, so this is the final piece that we will be inserting. What we're going to do is we're going to make the shaft, with here, with this face over here. Alright, so once you've done that, yeah, you can see it. This concentric, and then what we're going to do is that can now move freely front and back, right? And then we're going to sectional view. Okay, so there, have a look on this. Alright, okay, and then we're gonna select this face and mate it with here, the bushing. Alright, so once this is done, the rotor can no longer move freely, it can only rotate. Okay, go for mate, and we're going to choose width, and then we're going to choose here. Going to go with, choose here, no, we're going to choose this face and this face to here, and also here. So you can see now that even the coil holders are now at place. Coil holders and also the base flange part, they are now all fixed together, making it one whole DC motor. So this is how it's going to look. Alright. Yep. Okay. Okay guys. Yep. So once this is done, we are going to make one small adjustment fillet, and then we're going to choose 0.05 mm and then choose this face over here. Alright, so once you've done that, then the last part we will be doing here is that we're going to change from sectional view to normal view. Okay, so now that we've removed from our sectional view, this is the last mate we will be doing, which is we're going to mate the case to the cover. So now we can see that it's still moving. So what we're going to do is that we're going to mate here this face, so we're going to select this face, mate this with here, like that. Okay, this is how it's going to look inside the DC motor.